Good afternoon, my name's Andrew. I'm the co-founder of the Venus Project Design with my partner Julia, who's sitting over there. Before I go into the more detailed presentation of the Venus Project Design and the design of the circular cities, I'd just like to introduce the rest of the Venus Project Design team. So first of all, we have Ben McLeish, just over here, who you spoke before? No, never. Ben's our lecturer. We've got Tom Williams, our event coordinator. Jason Gleeson, who is over at the back there doing the audio and visual. And Mark Whitner and Stuart Dobson, who couldn't be here today, they're our web developers. They developed the website that we've got up here. The Venus Project Design was created shortly after myself and Julia, my partner, watched Zeitgeist Addendum shortly after it was released, and realised that we could help out on the design side of things for the Venus Project, as we both come from a computer-aided design background in the construction industry. Our initial goal was to create a global CAD agency that the Venus Project could use to develop up the construction drawings for the first TVP cities. It later worked out really that we realised that unless we actually got the funding and the opportunity from a country to actually build one of these cities, it was pretty futile to actually try designing one at this time. Because by the time we actually get the opportunity to do a city, the design will likely have changed by then, the technology will have changed by then, and there's a lot of variables involved with the design of the cities that could change by that time. So we later developed the website to include a global scientific and technical database. We've now got around 1,500 people, I believe, on that database. From everything from architects, engineers, neuroscientists, all the different scientific fields. We've got technicians from all different fields that are signed up there, so that if at some point in the future a country does decide to take on the Venus Project ideals and build the first city, we can then pull on that database and bring the people in that local area or that local country into the design of those first cities. Myself and my partner, we've also had a long-term interest in 3D computer-aided visualizations. This is some of the stuff in mid-process that we've been working on with the Venus Project. We also have a group of volunteers through the database that actually help us with the 3D modelling. So we're actually taking Jacques' thousands of sketches and creating 3D models out of those for visualisation purposes to show people what these cities may look like in the future. Okay, so having spent much time with Jacques over the last few years developing his sketches into 3D models and learning about the design principles he uses and why, I'd like to share some time with you of this today with a broader understanding of why the cities look the way they do, why they're circular, why the buildings are white. Many of the questions that are normally addressed, especially I get a lot of this on Facebook, people grilling me for hours of why things are the way they are. So we'll go into some of that now. Our current system of resource extraction is transportation through to finalised manufacturing and production of goods and their transportation to the end user. Is actually extremely inefficient in our current system. It's wasteful and it's outdated. And when you consider 99% of all materials produced in the US ends up in a landfill within 6 weeks, every tonne of garbage dumped takes 5 tonnes of material resources to produce. The waste in our current system is quite clearly out of control. And when you add into the mix that the cost of importing and exporting these goods all over the globe and the inherent pollution that is caused within this system, it's quite clear this is just a complete failure on all levels. And we can't continue to do this if we want to survive on this planet. The Venus Project cities are not built for architectural ego. And hence we need to be evaluated on a different set of criteria than we're used to. that of actual functionality. It's not something that architects are taught in our current schools. Just as we try to identify the root causes in our social ills within the Venus Project, we also need to understand the root causes of why we have the problems in the cities that we do currently. So we can understand the actual reasoning behind why Jacques designs the cities the way he does. The industrial areas are outside of the city, and where possible are self-contained resource, extraction and distribution nodes, with on-site production, design, manufacturing and production facilities all rolled into one. Connected via maglev freight trains to the main city hubs for delivery of goods produced, while reducing pollution in the city hubs drastically, whilst utilising a monorail passenger transport system between local city hubs. The pollution is almost completely annihilated from what our current system is. By having the design and manufacturing facilities located together at the same site, combined with on-site resource storage facilities, a huge amount of energy and efficiency is saved. And when you add to this the fact that transportation of material resources and finished goods is handled by maglev trains, by clean, renewable energies, and the removal of unnecessary shipping and transportation of those resources from the source of extraction to the manufacturing plants, the effect of intercity traffic would be immense, not to mention the huge saving of both human and labour resources. Where possible, all goods produced would be biodegradable or recyclable. And for example, in the case of electronic goods, these would be designed with each individual component being upgradable, utilising standardised parts and connectors, reducing the amount of waste, and technology improves, products become outdated, and when you consider the various options we have for creating natural plastics, for example, palm oil or hemp oil, for example, as well as genetically engineered plastics, our reliance on our current oil is almost completely wiped out. The only reason we still use oil now is for the profit incentive, because it's not profitable to invest into renewable energies at this time. Many people initially see Jacques' work and thinks to themselves, it's just a fantasy, it's a big utopian dream, The buildings all look like something from Star Trek, never happen. They don't look at the purpose behind the architecture. And it's very difficult for us to present the architecture in the way that Jacques has designed it in one book or one video. It's important for us, if we are serious about conserving the resources of our planet, that we understand that the function must become the dominant value over aesthetics, even though this is very difficult for many due to our current indoctrination into our materialistic and wasteful consumerist aesthetic culture. The circular arrangement of the city needs less energy and materials in transportation of goods and services and people. Also, it's easier to make an inbuilt transportation system in a circular system. The routing of transportation is linear and radial, and therefore more efficient. You don't need traffic lights everywhere. You don't need roundabouts everywhere. Much of the transportation would be off the ground. The on-ground transportation would be for the emergency services to get to people if they have accidents or if someone's ill in their home or, etc. The transportation between city hubs would be through, via maglev or monorail, depending on the distance. With the city being designed in a circular arrangement, you only ever need to design 1/8 of the city. And then we array it to become a circular city. This would save a huge amount of time on the actual design process of creating these cities. The standardisation of buildings is a more efficient use of resources if we're serious about minimising waste and maximising efficiency. For example, if you look at some of the buildings in London, depending on the level of the building, you have different size windows. You have you might have 4 or 5 glazed windows in a row, and then a single one, and then a double, and then in order for us to produce those, we have to have different designs for them. It takes a different amount of materials for each of them to be created. If we standardise those, it becomes a much more efficient process. becomes cheaper on resources, it's easier to make. We need to start thinking about the actual functionality of our cities, of our buildings, to take this into account rather than just looking at how the building looks, whether it's aesthetically pleasing to my cultural values, which are different from your cultural values or yours. Many of the structures are dome-shaped. The reason for this is that the dome structures are structurally stronger than current home types and won't collapse in cases of earthquakes. These buildings have more surface area for direct sunlight. The reason they're white is because we would be using ceramic skin that would have embedded solar panel cell or solar cells, so that the actual homes themselves are actually self-generating homes. They generate their own electricity. Obviously, this would only be used in countries where there's direct sunlight for most of the day, but they would also be combined with other energy sources within the city. So you'd have wind power, tidal power, depending on whereabouts the city was built. Domes also take less maintenance from the typical cuboid homes that we're used to. And due to the increased surface area, homes like this can easily generate their own heating and cooling. And house power. In countries where this is not enough sunlight to do this, we would obviously use different technologies. Heat source, heat exchangers, etc. Additionally, these structures are easily constructed using 3D printing technologies, as one continuously sealed mould with openings left for windows, although the latest in technology is suggesting that within probably the next 3 or 4 years that we would actually be able to do 3D printing with multiple materials in the same mould. So you'd actually be building the house with the concrete and the windows all in one, all sprayed in the printer. Sorry. The current printers that we've got are typically table-sized. There aren't any, apart from the one in California University, which they're now using to build complete brick walls with the services inside the actual walls. There's no reason, apart from the monetary reason, of why we can't make these machines absolutely huge. They could be the size of this room, for example, printing off houses, travelling down tracks, printing off complete, housing areas for these cities in a number of days rather than, several years as it would currently take with our current construction methods. Currently, we conceive of homes within the restrictions of our habits and our indoctrination into our culture and architectural design of that, styles of that culture. We consider it normal to live in a square brick and wood-based house, which often breaks over the course of its life, requiring endless maintenance, and is often flattened in major storm, as we see year upon year, especially in this country.